Hello everyone, this is grade 6, module 5, lesson 13 problem set. So we'll start with question 1, and it says, determine the volume of the rectangular prism. And I have two different formulas I could use. I could use volume equals length times width times height, or I could use volume equals base area times height, and that's why I'm capitalizing it. So I see that I have an area in here. And when we say base area, we mean area, meaning a length times width. And I then have a measurement here. So if I'm given the area, I'm going to go with this formula. So for 1, I'm going to do volume equals base area times height. And what I'll then do is my substitution. And my area is 37 centimeters squared because area is in square units. And I'm going to multiply that by 1/3 centimeters. And I could put my dot in there. I'm going to put parentheses in to separate those two out, just so I can see them as what they are. My next thing then is to multiply. And I'm going to multiply across. So 30 times 1 is 30. 7 times 3 is 21. And I'm going to bring my units. I have centimeters squared times centimeters, which means centimeters cubed. And I can then reduce this or simplify this down. And there's a couple ways I can do it. I can turn it back to a mixed number. I can do a reduced fraction. So I'm going to put it back into mixed number form by doing 30 and dividing it with 21. And I get 1 and 9 21st, and I know that I can take 9 21st and divide it by 3 over 3, because that's a common common factor. So really I'm going to end up with 1 and 3/7. So 1 and 3/7 centimeters cubed. Now if I wanted to just take that 30 21st, I could then divide it by 3 over 3 and get 10/7. So it could be that, or it could be 10/7 centimeters cubed. Either way, I want to simplify the fraction down, or I want to turn it into a mixed number. I don't want to just leave it as 30 over 21, although that is an equivalent fraction. So for number 2, it states, determine the volume of the rectangular prism in problem 1 if the height is quadrupled. So multiplied by 4. So more or less what I'm going to do is take the height and multiply it by 4, and I know for this one I'm going to use this 1/3 as my height, and I would do 1/3 times 4. I got to make it 4 over 1, so that's going to get it 4/3. So I would then take 4/3 and plug it in for the 1/3 and then re-multiply. So my volume equals base times height, but when I substitute, it's going to be 37 centimeters squared times 4/3 centimeters. Right. And that's not the answer. I actually have to go through and solve that out, but I'm going to leave that one to you. Then we need to determine the relationship between the volumes in problem 1 and this prism. And you're going to see that the answer is going to look a little different from 1 to answer 2, and you want to state how that answer is different. So let's take a look now at 3. And we'll go through 3 and then I'll jump to the next page. So we'll slide down and I'll slide over just a little bit so I can write next to it. So for 3, the area of the base of the rectangle prism can be represented by B and the height by H. Write an equation that represents the volume of the prism. Well, it's the one that we've been using. capital B tells me area of the base, or base area, and it's going to be multiplied by h. And I don't have to put that symbol in between because I know if two letters are next to each other, it means multiplication, but I could put my dot in there if I really wanted to. I would not put an X in there, the multiplication sign, the operator sign, the X, because it's going to look like a variable. But we don't need one in there for that one. So that's the first one. Let's look at B. If the area of the base is doubled, write an equation that represents the volume of the prism. So I'm using the same formula, but now I have to double the area of the base, or the base area, meaning 2 times. So 2 times B times H. Because I have to multiply the base times 2 and then multiply it by the height. Commutative property says I can go either way, but that's how I'm going to show it. C. If the height of the prism is doubled, write an equation that represents the volume. So I'm going back to my original formula of V equals capital BH, and this time it's the height. So V equals capital B 2H. And all of these are multiplications, so I can put dots in between them, but I'm going to leave it. So now I'm showing that I have to multiply the height by 2. D says compare the volume in parts B and C. What do you notice about the volumes? And the first thing I see with the two equations here, the formulas, is that they both have a V for volume, they both have a B, they both have a 2, and they both have a height. And I know the commutative property says I can multiply in any order, and I'm still going to get the same answer. So that tells me that, and I'm going to bring this down here. So this is D. Volumes of B and C are equal. Because they're essentially the same formula, just the 2 is in a different position, but with multiplication it doesn't matter what position it's in. So they're equal. Now if we look at E, and I'm going to do E right down here. Write an expression for the volume of the prism if both the height and the area of the base are doubled. So both the base and the height are doubled. So volume equals 2B times 2H. And I know with combining like terms that we talked about earlier in this module, I can combine those numbers because it's multiplication across. I can really separate this out into V equals 2 times B times 2 times H. Now I can combine the 2 and the 2. 2 times 2 is 4 times B times H. So I could use this formula, or I can use this formula. And either one is good. Let's take a look over at page 2. So if we look at question 6, we're going to use this rectangular prism here to help us out with the chart down below. So the first thing I want to do with this chart is take a look at the length, and I see that I have my dimensions here. So volume equals length times width times height. My length for this is 8 centimeters times 1 times 1.5. And I can calculate that out. 8 times 1 is 8. And then I would need to multiply it by 1.5. So I can put these all over 1. For my whole numbers. And then I'm going to change this into a improper fraction. And the reason why I can do 2 times 1 is 2 plus 1 is 3. The reason why I can do that, again, and I always like to show this, is when I'm talking in terms of units, that's actually a 2 over 2. 2 over 2 equals 1 whole. So 2 over 2 plus 1 over 2 gets me 3 over 2. That's why I can change it. So now I can multiply. 8 times 1 is 8, times 3 is 24. 1 times 1 is 1, times 2 is 2. And I'm at centimeters cubed now because I did 3 different centimeter units. And if I divide that, 24 divided by 2 is 12. So I get 12. And I'm going to put in my units for this one. Now, what if I take half of the length? So now it's not 8 times 1 times 3 halves. I need 4 times 1 times 3 halves. And the reason why I'm going to keep it at 3 halves is because I already changed it over here. And I know it's going to stay the same. So I put my 1 over 1 to make it a fraction, my 4 over 1 to make it a fraction. Now I multiply. 4 times 1 is 4, times 3 is 12. And 1 times 1 times 2 is 2. And I'm at centimeters cubed. And if I do 12 halves, or 12 divided by 2, it's going to be 6. So now I'm making some connections here that if I take half of the length, I'm taking half of the whole volume. So if I take a third of the length, I am going to take a third of the whole volume, starting up here. So the way that would look, 1/2 of L is 8 over 2, because I have to take half of 8, and that's how I'm doing it. I'm dividing it by 2. If I want to take a third of that, it's 8 over 3. So that is what would go in place into my formula if I needed to. So I'll do one more, and then I'll let you go for this one. And I'll do the 1/3. So volume equals length times width times height. My length now is 8/3 centimeters times 1 over 1 centimeters times 3 halves centimeters. And again, I'm using 3 halves because I already converted it up here. So 8 times 1 times 3 is 24. 3 times 1 times 2 is 6. And that's centimeters cubed. And I'm going to end up with 4 centimeters cubed because 24 divided by 6 is 4. So you're seeing, now if I take a fourth of my length, it's 8 over 4. That's my new length that I can put in. 2L means 2 times the length. So if I do 2 times that, I'll get 16. So you're finding ways that we can now use what we have to plug in. So 1/2 of 8, we did 4 up here. We put it in over here. 8/3, we can't really figure that out, so we're going to leave that as the fraction, which we did over here. 8/4 is really 2, because 8 divided by 4 is 2. And then we'll plug in these new lengths into our formula, and we'll find the volume. So if we take a look down below, you're going to answer some questions on that. And I'll answer B. How did the volume change when the length was 1/3 as long? And we know that our original volume was 12. And our 1/3 was 4. 4 is 1/3 of 12. So it changed by a third. We pretty much divided 12 by 3 to get our 4. So if we take 1/3 of the length, we're taking 1/3 of the volume. And that's what you'll be doing for for C and D. You'll have to answer a few questions. This C is tripled. And then D is kind of wrapping the whole things up with relationship of volume to the length. I hope this helps. Thanks for watching, and good luck on your problem set.